My dear friends, welcome to my next video session. So in this session I am going to discuss about the multi-dimensional arrays. In my previous videos I have discussed one-dimensional array. So we know that there are two types of arrays. One is one-dimensional array and the second one is multi-dimensional arrays. So multi-dimensional arrays means more than one subscript will be there, okay, or two or more dimensions will be there, or two or more subscripts will be there, and we call such arrays as multi-dimensional arrays. Okay, so example here, see, these are the examples of multi-dimensional arrays. You see A10 B10. So A10 is written within square brackets, another 10 is written within square brackets. So this first 10 is one subscript, another 10 is another subscript. Unlike our one-dimensional array where we use only one subscript. So this is just, if you write only this much, it is called one-dimensional array. So because here only one subscript is there. So but here in this case we have A10 B10. So we have two subscripts. So A is name of the array and we have two subscripts, and that's why it is called two-dimensional array. Suppose if you consider array B, name of the array is B. So here you can observe that there are three subscripts. One is 10 within square brackets, 15 in another square brackets, and 20 in another pair of square brackets. So totally there are three dimensions or three subscripts, and it is called three-dimensional array. So like that we can have any number of subscripts. You can observe here array C has got C of 5, like that it goes on up to n. Okay, so it is called n-dimensional array. C is called n-dimensional array. A is called two-dimensional array. B is called three-dimensional array because three dimensions are there. Okay, so like that array may have two dimensions, three dimensions, or n dimensions, and such arrays we are going to call it as multi-dimensional array. Okay, but we focus in this video on two-dimensional arrays. Let us see what are two-dimensional arrays. And these two-dimensional arrays are also known as matrices, or one two-dimensional array is called matrix. We call it as a matrix. So we know that what is a matrix? It is arrangement of numbers in the form of rows and columns in a tabular form. Okay, so that is called a matrix. See here, in matrix data is arranged in tabular form, that is in the form of rows and columns. So that's why this matrix or two-dimensional array is referred by how many indices? Two indices. Okay, there are two subscripts also we can call. Okay, the first subscript refers to rows, and second subscript in a two-dimensional array refers to columns. So that's why in two-dimensional array, which is also known as a matrix, so we have got two subscripts. So first subscript is row and second subscript is column. So example, see here, example int b10 10 semicolon. Here int is the data type, b is name of the array, and this is 10 means the 10 your matrix B or array, two-dimensional array B has got 10 number of rows and 10 number of columns. See, the first subscript 10 refers to rows, so B array or matrix B has 10 rows, and second subscript refers to columns, so 10 columns. Okay, so this is about the two-dimensional arrays, and let us see how to declare two-dimensional arrays. Okay, so this once we know what is a two-dimensional array, so we should know how to declare two-dimensional arrays, because why we do declaration in C language? To reserve memory. So unless you declare the array, then memory is not reserved to store the elements of array. So like that, unless you declare matrix, okay, so memory is not reserved to store the elements of the matrix. So that's why declaration of two-dimensional arrays is very important. So let us, what is the syntax of declaration of two-dimensional arrays? So this is what the syntax you can observe here: data type, blank space, then you have array name followed by within square bracket row size, and within another pair of square brackets column size, and terminated by semicolon. So this is called the syntax. So data type, blank space, array name, then within a pair of square bracket row size, and within a pair of another square braces column size, terminated by semicolon. you observe that here row size, after that comma is not there. Okay, and this is the example. See, you can observe here example. So data type is int, array name is A is the array name. Here array name is just A is the array name. Row size is 3, column size is 5. That means matrix A is said to have 3 rows and 5 columns. So because 3 rows and 5 columns are there for matrix A, so many locations have to be reserved. So that's why this declaration int A of 3 5, it is going to reserve 3 into 5 15 locations. 3 rows and 5 columns means maximum you can store 15 elements into that array A. Okay, so another example for declaration. So data type is int, array name is mat1, row size is 3, column size is 3, terminated by semicolon. So this is what the declaration of two-dimensional arrays. So remember, before using a two-dimensional array, it has to be first declared, okay, in the declaration part of your C program. So what happens when you declare an array? Memory locations are reserved, but the values are not stored. Elements of matrix are not yet stored, just memory is reserved to store the elements. So how to store the elements? One method is we can initialize two-dimensional arrays. By initializing two-dimensional arrays, we can store elements into an array. So that is into the matrix. Here just remember, two-dimensional array is nothing but matrix. So how to initialize a matrix? Okay, so why we have to initialize a matrix? To store the elements into matrix, one method is by initialization. So that is what called initialization of two-dimensional arrays. We know that what is meant by initialization. Initialization is nothing but storing the elements during declaration itself into the array. Even initialization of variable is nothing but assigning values during declaration of the variable itself. Like that here, initialization of a matrix or two-dimensional array means during declaration of the matrix. Here, see here we are declaring the data type. So during declaration itself, we are going to store the elements into that matrix or elements into that two-dimensional array, and that process we call it as initialization of two-dimensional arrays. So syntax, what is the syntax for initialization of two-dimensional arrays? It is similar. So that is similar to the declaration of two-dimensional arrays. See, this is what the syntax, same line we copy here, except semicolon. See, data type, array name, then row size, column size. So instead of semicolon, what you have to do? You have to write equals, means assigned a value here. Equals is nothing but assignment operator here. So assigned a value within pair of curly braces. You can observe here, this is pair of curly braces. Within pair of curly braces, I have indented this one. See this one. Okay, this we have to write. Each row should be written within a pair of curly braces. See, this is the first row, then terminated by comma, then second row terminated by comma. Like that you can have up to m number of rows. Okay, see, within a pair of, after assignment operator, within a pair of curly braces, you have to write row elements within curly braces and separated by it or terminated by comma, comma, comma. Of course, last one doesn't have comma. Last row does not have comma. So this is very important. What is this V0 value? V is nothing but value. Value 01 means 0th row first column. So this is called 0th row first column. Value or element present at 0th row first column. This is value of 0th row second column. Like that, 0th row nth column. Then V11 is nothing but first row. Value present at first row 0th column. No, this is not 01. So this should be V00, V01. Like that, V0n. So this is V10, first row 0th column, first row first column, first row nth column. Like that, this is V2 0th column. We have this as 0th column. V second row first column, second row second column. Like that, second row nth column. Like that it goes on. V mth row, this is 0th column, mth row first column. Like that, mth row nth column. Okay, so this is how we are going to initialize the elements into array during declaration itself, and that is called initialization of two-dimensional arrays. So remember, what is the syntax? Data type, array name, within a pair of square braces row size, another within pair of square braces column size, then assignment operator, then within a pair of curly braces we write row elements, row 0 elements within curly braces, comma, row 1 element within curly braces, comma, row 2 elements, second row elements within curly braces, comma, like that. Row, last row or mth row, okay, elements. Here we don't have semicolon, okay. So and terminated by semicolon here. It is terminated. Declaration is always terminated by semicolon, okay. So this is what initialization of two-dimensional arrays. So let us see with an example. See, what is this example here? You can observe that this example, see, data type, see, data type here. What is the data type? Int. Example 1, observe here, data type int. Array name is table. Table is the array name given. Then within square bracket row size. So what is row size? 2. Then within square bracket column size. So what is column size? 3. So that means what? Your matrix called table has 2 rows and 3 columns. So this first subscript is always for rows and second subscript is always for columns. So table is name of the array having 2 rows and 3 columns. How the elements? So what are the elements of first row? What are the elements of second row? See, 0th, see this one, 0 0 0 means first row element 0 0 0 0, comma, within pair of curly braces. Then second row elements. All these row elements are once again included within a pair of curly braces. This is important. This one. This is within a pair of curly braces and terminated by semicolon. See here, opening brace. So opening brace. 0th row elements. What are 0th row elements? Here this one. 0, 0, 0 within curly braces. After that, comma. Then you have next row. Only 2 rows are there. So next row elements within curly braces. So within curly braces you have next row element. That is last row elements. Last row elements. See, last row doesn't have comma. So last row doesn't have comma. Close. So this one, close semicolon. Close semicolon. So this is what example of initializing. Initializing what is called a two-dimensional array. So this is nothing but we are going to name them as. So here this is table, 0, this is called 0th row, 0th column, 0th row, first column, 0th row, second column. This is tables, first row, 0th column, first row, first column, first row, second column, like that. We'll come to know very short. Another example for initialization of two-dimensional array. Data type int, name is table. So same initialization can be written in other words also, in the same line, in single line. So this is written in a single line here. Same int table 23, int table 23, written in a single line. Okay, see, same opening brace, opening brace. Then this one, see this one, comma, comma. Then next row, then next row, same. Then close semicolon, see, close semicolon. So you can write in this way also, initialization of two-dimensional arrays. So same thing you can also write it like this also. Say same int table 2 of 3, all elements you can write. Say assigned a value within a pair of curly braces, all elements you can write. Here 2 rows, 3 columns, 2 rows and 3 columns. First row 3 columns it will consider 0 0 0. Then second row 3 columns it will consider 1 1 1. So within a single line also you can write it. Okay. So just observe here, initialization of two-dimensional arrays is written in 3 methods. Okay, so as per the syntax, so this is the syntax, this is the syntax, and as per the syntax you have to write the examples. So we can write the examples. So why we have to initialize? What happens when we initialize a two-dimensional array? So if we just declare only this much, declaration terminated by semicolon, so 6 locations will be reserved for a table. But if we initialize, these values are stored into those memory locations. So that is what initialization. It's one method. This is one method of storing the elements into matrix, initialization. We use another method, that is through scanf statement or through assignment statements also you can store elements into table, or through scanf statement you can store elements into a matrix. Okay, that you can do. So next comes, this is all about declaration of array, two-dimensional array, and initialization of two-dimensional array. So next we shall discuss about memory mapping for two-dimensional arrays, means how the memory looks like for these two-dimensional arrays. So that we shall consider. See here, this is the memory map for the following two-dimensional array. Okay, so here we have int a33 assigned a value. See, this is what initialization. Data type, array name here is a, row size 3, column size 3. So we have written a33 within square brackets, assigned a value, assignment operator. See, within curly braces we have written first row elements are written once again within curly braces 1, 2, 4, second row elements 5, 3, 6 within curly braces, third row element 7, 5, 9 within curly braces. So last row doesn't have comma here, close semicolon. So this is initialization. So how memory map, what is meant by memory map means in memory how these elements are stored, 1, 2, 4, 5, 3, 6, 7, 5, 9, how they are stored. Okay, see here, see this is the memory. So first one A0, see how we refer to this one is referred to as an element present at 0th row and 0th column. So that's why see here A0th row, 0th column is what? 1. Then how we refer this 2 is accessed or referred as name of the array. We always access the elements of the matrix with the subscripted variable, means along with array name and its position. So what is the position of 2 here? The position of element 2 is 0th row. I said in arrays, whether it's a one-dimensional array or two-dimensional array, the position will always start from 0. So that's why this 1 is referred as 0th row, 0th column. 2 is referred as A of 0th row, first column. Always we have to consider first subscript as row and second subscript as column. How 4 is accessed? A of 0th row, 2 column. So A of 0, 2. So that's what here written. See, 1 is that 1 can be accessed by A of 0, 0. 2 is that what element present at 0th row, first column. A 0th row, first column is 2. Then 4 is A, it is present in 0th row, second column of A. See, A02, 0th row, second column 4. So like that 5 is accessed as 0, this is row number 1, column number 0. See, 5 is accessed as A of 1, 0, means A of row number 1, column number 0. 3 is A of 1, 1, row number 1, column number 1. A of 1, 1 is 3. Like that 6 is nothing but A of 1, 2. 7 is nothing but A of row number 2, column number 0. A of 2, 0 is 7. 5 is row number 2, column number 1. So A of 2, 1 is 5. 9 is row number 2, column number 2. A of 2, 2 is 9. Okay. Suppose if your memory location starts at 2000, you know that array is declared as of data type integer. Now integer needs 2 bytes. So this why addresses range with value 2. See, we go on adding 2 to the address. 2000 plus 2, 2002, 2004, 2006, 8, 10, 12, 14, 16, like that, because integer needs 2 bytes. So this is what called a memory mapping, means or how your array elements are stored in memory and how they are accessed. Okay, first row number, second subscript refers to column number. So A of 0, 0, like that, A of 1, 1, A of 2, 2. A of 2, 2 is nothing but an element present at row number 2 and column number 2 of array A, which is 9 here. I think this is very clear. Okay. So once we discuss this, let us focus on reading two-dimensional array. So this one using here we have used initialization of two-dimensional array. So using initialization we have stored elements into array like this 1, 2, 4, 5, 3, 6, 7, 5, 9 through initialization method. You can also store elements into this two-dimensional array by scanf statement, through a scanf statement, and that is what called reading. Here it is fixed. If you use initialization of two-dimensional array, the elements are fixed. Any number of times you execute the program, it is fixed. But every time we want to store different elements, means we have to go for scanf statement. So that is what reading a two-dimensional array tells us. Okay. Say two-dimensional array, say A of mn means array name is A and m number of rows and n number of columns it has, can be read using row major order as follows. Okay, means first here it uses two for loops, that is nested for loops. Reading a two-dimensional array uses, remember, nested for loops, one for loop within another for loop. Okay, so outer for loop always refers to row number and inner for loop always refers to column number. Remember it. Okay, this is very important. Outer for loop always refers to row number, rows, and inner for loop always refers to columns. So we have rows and columns, that's why we use two for loops. Then we use a scanf statement within body of the inner for loop. Scanf %d comma ampersand a of I j. M and n is the order, but how many elements? M number of rows and n number of columns are there. So m number of rows we take first for loop. For I s and l is 0, I is less than m, I plus plus. Okay. For within body of the outer for loop we take columns. Okay, means I is equal to 0 means 0th row. I is equal to 0 means 0th row. In 0th row, how many elements are there? N number of columns are there. Means each column element has to be typed. Okay, that is to be stored into memory. That can be achieved by using scanf statement, or you can read it by using scanf statement. Means it displays just a blinking cursor on the screen and waits for the user to give the input data. Until user gives input data, the scanf statement does not continue with the execution. Okay, right. So this is very simple. Reading a matrix, you can call one for or two for loops. Outer for loop always refers to rows and inner for loop always refers to columns, and body of the inner for loop is scanf. So we will come to know with an explanation afterwards. We will explain what is this reading two-dimensional array. Okay. So next, writing two-dimensional array means what? Same thing. This scanf should be replaced by printf. Very simple. So that is called writing. Means once the elements are present in array in memory, so in memory they are not visible. So that's why to make them visible they have to be brought to the screen. So how do you bring the elements in the memory onto the screen? You use printf statement, and that process we call it as writing two-dimensional array. Same for loops we use. Instead of scanf we use printf. Okay. A of ij, printf % comma a of ij, and here we use one printf \n. Printf \n means after printing first row elements. See here, see, just observe the body of outer for loop for reading and writing. Here body of the outer for loop has only one for loop here, no printf statement. Observe here. Okay, whereas for writing two-dimensional array we use a printf statement. Why we use this printf statement means after displaying first row elements, next row element should be displayed in the next line. So before this outer for loop ends, the cursor should be brought to the next line to display the elements of next row. Then only I increases. See, I plus plus. Then it displays I is equal to 0 means 0th row elements will be printed here using inner for loop. Once 0th row elements are printed, then the cursor should be brought to the next line. So that's why we use printf \n. Then I value has to be increased. I becomes 1. I plus plus means 0 becomes 1. Means row number 1 elements have to be printed. Once again this for loop is used to print the row number 1 elements. After printing row number 1 elements, the cursor, the print control has to be brought to the next line. Once again printf \n. So like that, to print each row elements separately in a new line, we use this printf \n. Within inverted comma we write just \n, which takes the print control to the next line. So this is very simple, reading a two-dimensional array and writing a two-dimensional array. So let us trace these things and we will come to know. After that we write one program to read and write two-dimensional arrays. Then the things will be more clear. So this is what reading two-dimensional arrays, writing two-dimensional arrays we have discussed. Okay. So next we shall discuss, we will write a program. We will write a program to read and write two-dimensional arrays. Once we write the program, let me trace the program. So you will come to know. So this is the program to read and write two-dimensional arrays. This is just one comment. Comment is non-executable statement. Okay. So preprocessor directive hash include stdio.h. So main code, I'll just go to main code for reading a matrix. This is called reading a matrix. Reading matrix comment. I have told you it will have two for loops. This is the main code. For I s and l is 0, I is less than m, I plus plus. For j s and l is 0, j is less than n, j plus plus. We are going to assume that our matrix has got, our matrix name is A. A is name of the matrix. How many rows it has got? M rows. How many columns it has got? N columns. So we assume that my matrix has got m number of rows and n number of columns. And name of my matrix is A. Okay. So A, M, N is my matrix. Okay. So depending upon what values we are going to read for m and n, so we are going to enter so many elements. M into n number of elements we have to enter. See, two for loops. Within that, if we use scanf statement, scanf percentage ampersand a of ij, it is called reading a matrix. So writing a matrix means what? Same code with printf statement. Same code with just printf statement. After this scanf control comes out, we use on printf backslash n. This is important. Okay, right? Now I'll just copy this, reading a matrix and writing a matrix. Why this one? Not necessary. Okay. So let us see here. Let us take value of m and n, order of matrix value of m and n. Let us take it as 2 and 2. My matrix, for simplification, I have taken 2 cross 2 matrix. So read values of m and n. So my value of m is equal to, let me take it as 2, and n let me take it as 2. Okay, right? So here this is reading a matrix. See, I am going to execute this for loop. I have taken A is my array, which contains 2 rows and 2 columns, 0 through and first column. This one 0 through and first column, and 0 through and first row. A has 0th column and first column. Okay, 2 rows and 2 columns. Okay, so m is equal to 2, n is equal to 2, 2 rows and 2 columns, and name of the array is A. Okay, for I s and value 0, so let me take I s and value 0. Then is I less than m? What is value of m? 2. Is I 0 less than 2? Yes. Yes means yes. The condition is true means what? Execute body of the loop. So this is body of outer for loop. Okay, what is body? Inner for loop. Once again, for j s and value 0. Now so j is initialized to 0. Is j less than n? N is what? 2. Is j less than 2? Yes. S means execute its body. What is its body? Scanf a of ij, means you have to type the value. So let me type 3 is my input, means through keyboard I give 3. So that 3 will be stored here at position. You observe here a of ij, means in array A at position ij. What is I value? 0. What is j value? 0. So at a of 0 0, my element 3, typed value 3 is stored. Okay, then this is end of inner for loop, means j plus plus. So j plus plus means now j becomes what? 1. J becomes 1. Then immediately condition is verified. Is j less than n? J is 1, n is 2. Is j value less than n? Yes. Yes means what? Execute body of the loop. What is body of the loop? Scanf percentage d ampersand a of ij, means we have to give the input. Scanf means we have to type the value through keyboard. So let me take 5. So where that I'm going to type 5. Where that 5 is stored? 5 is stored at position A of ij. Now I value is 0, j value is 1. So A of 0th row, first column. So here I am going to my 5 is going to be stored. Okay. So then end of this inner for loop. End of inner for loop is nothing but j plus plus. So j plus plus is nothing but j becomes 1 plus 1, 2. Immediately after this plus plus, control goes to condition. Is j less than n? So j is 2, n is 2. Is j less than n? Yes, no. Condition is false. They are equal. So condition is false. Condition false means control comes out to this outer for loop end. So outer for loop end means I plus plus now. I becomes what? 0 becomes 0 plus 1, 1. Immediately condition is verified. Is I less than m? M is 2, I is 1. Yes. 1 is less than 2. Yes, S means execute body of the loop. Now what is body of the loop? Once again for loop is executed. For j assigned value 0. Now j becomes how much? 0. New value of j becomes 0. Is j less than n? Is j less than n? N is 2, 0, j, s. J is less than n. S means execute body of the loop. Once again scanf statement is executed. You have to give the input. Let me give the input 6. I am going to type 6. 6 will be stored at position what? A of ij. A of I is 1. J is 0. A of 1, 0. A of 1 means this one. 0 means this one. So at this position my 6 is stored. Okay. Then this is end of inner for loop, which is nothing but j plus plus. So j plus plus is nothing but j becomes now 1. Okay. Then condition is verified. Is j less than n? J is 1, n is 2. Yes. S means execute body of the loop. So what is body of the loop? Scanf means you have to give input. Let me give input 4. So where that 4 will be stored in memory? At A of I, j. I is 1, j is 1. So A of 1 means 1th row, 1th column. So here 4 is stored. So now this is my 3, 5, 6, 4 are the elements stored. Now what happens? End of this one means j plus plus. So j plus plus means now j becomes 2. Then immediately condition is verified. Is j less than n? J is 2, n is 2. No, they are equal. Equal means control comes out of inner for loop. So control comes to this. So this means I plus plus. Now I plus plus is nothing but I becomes what? 1 plus 1. It becomes 2. Okay. Then immediately outer for loop condition is verified. Is value of I less than m? Value of I 2 less than m 2? No, they are equal. They are equal means condition false means control comes out of outer for loop. See, now by this time in array A you have 0th row 0th column 3, 0th row first column 5, first row 0th column 6, first row first column 4. So A of 0 0 is 3, A of 0 1 is 5, A of 1 0 is 6, A of 1 1 is 4. So this is how 3 5 6 4 are typed values, input values stored into array A or matrix A. Okay, don't get confused, right? This 0 and 1 are row numbers, 0 and 1 are column numbers. This is what called reading matrix. So writing a matrix means what happens now? Let us see writing a matrix. So once again, now already matrix we have got. Okay, the given matrix is it displays on the screen. The given matrix is, okay, let it be for I assigned value 0. Now I am going to remove these values. Once again I am going to trace 0. I assigned value 0. I is less than m. Is 0 less than 2? Yes. S means execute body of the loop. What is body of the loop? Once again for loop. For j assigned value 0. See, observe here. J assigned value 0. Then is j less than n? S. 0 is less than n. S means what? Printf percentage d a of ij. So I will leave one blank space here after d. Printf percentage d a of ij means on screen it will display a of ij. What is a of ij? I is 0, j is 0. What is a of 0 0 0 0? A of 0 0 is what? 3. So 3 is displayed on the screen. Okay. Then this is end of inner for loop means j plus plus. So j plus plus means j becomes now 1. Then immediately condition is verified. Is j less than n? J is 1, n is 2. Yes, S means execute body of the loop. What is body of the loop? Once again printf statement. Here some blank space is printed. Printf after percentage d blank space comma a of ij. What is a of ij? I is 0, j is 1. A of 0 1. What is a of 0 1? 0th row first column 5. So 5 is printed. Means 3 5 are printed. Now see, 6 should not be printed on the same line. Okay, what happens you observe here. Okay. Then control comes here, this is nothing but j plus plus, so j plus plus means j becomes 2. Okay, then condition is verified, is j less than n, j is 2, n is 2, no, they are equal. Equal means control comes out of this for loop, means where the control comes out of for loop means printf backslash n. So printf backslash n means next item to be printed will not be printed on the same line, it will be printed on the next line. Okay, then end of outer for loop reached. End of outer for loop is nothing but control comes back to I plus plus, now I becomes 1. Then immediately condition is verified, is I less than m, I is 1, is 1 less than m2, yes, s means execute for loop. Once again inner for loop is executed. For j assigned a value 0, now once again j becomes 0. Then is j less than n, j 0, n is 2, yes, 0 is less than 2, yes, execute body of the loop. What is body of the loop? Printf percentage d a of ij. What is a of ij? A of I is 1, j is 0, a of 1 0, see, a of 1 0 is 6, so that 6 will be printed in the next line. Okay, then end of inner for loop is nothing but j plus plus, so j plus plus means now j becomes 1. Then printf percentage d a of ij, a of ij, so print control comes to next position here, a of ij. What is a of ij? I is 1, j is 1. What is a of 1 1? A of 1 1 is nothing but 4, so 4 is displayed. Okay, this is end of inner for loop means j plus plus, so j plus plus means now j becomes 2. Immediately condition of inner for loop is verified, is j less than n, j is 2, n is 2, yes, s means control comes out. Okay, so control comes out means control comes to printf statement, printf backslash n. Now print control comes to next line, whatever is to be printed that will be printed in the next line. Okay, then end of outer for loop, so end of outer for loop is nothing but I plus plus, I plus plus is nothing but I becomes 2, 1 plus 1 2. Then immediately condition is verified, is I less than m, I value is 2, m value is 2, is I value less than m, no, they are equal. They are equal means control comes out, control comes out here. Now see, you can observe your matrix elements 3 5 and 6 4 are printed like this. So you can observe here what is the role of this printf backslash n. If you don't write that in program, we will come to know. Let me remove that and you will see what will be the output. Okay, so same thing, so we shall execute in using turbo compiler. Okay, so this is what reading a matrix and writing a matrix. Okay, or reading an array, two-dimensional array, and writing a two-dimensional array. Okay, so the complete program is written. Once you know how to read and write code, the complete program is written like this. See, hash include stdio.h void main. So here we have declared row size and column size, or order of the matrix, m rows and n columns. Then our array has to be declared to reserve the memory, a of 10 10, a of 10 10 means 10 into 10, 100 locations are reserved to store elements of a. We use two for loops, so that's why first for loop variable always I, second for loop variable always j. Okay, loop variables I and j, two loop variables I have taken. So clear screen. Now first we should know what is order of the matrix. That's why first we have to, whether it's a 2 cross 2 matrix or 2 cross 3 matrix or 3 cross 3 matrix or 3 cross 2 matrix. Now that we should know first. That's why m and n values decide what is the order of the matrix. If m is 2, n is 2, it is 2 cross 2 matrix. If m is 2, n is 3, it is 2 cross 3 matrix, means 2 rows and 3 columns. So that's why first you have to read the order of the matrix. Okay. Once you read the order of the matrix, then reading matrix. One comment I have taken, non-executable statement. One printf statement in program I have written just for proper impressive output. Just enter matrix elements. Here we have scanf statement. No, that scanf statement should be preceded by printf statement. Outside for loop I have written. Otherwise it will repeatedly displayed if it is written within the loop. So that's why outside the for loops I have written printf. In new line enter matrix elements, means 2 blank lines will be there. Okay, after printing this line, once again the control goes to next line, backslash n I have used. Okay, so this is what the code we have discussed for is and ls0. This is body. See, you observe that body of the loop is enclosed within curly braces. During program execution I will just make changes and let you know what happens if I remove those curly braces. Okay, then this is what the code we have discussed, traced it, writing a matrix. This is the code. and for this is just comment. Following code is for writing a matrix. So one for our just proper display of the output, I used one printf statement liberally. The given matrix is after backslash and backslash n. So to control goes next 2 lines. Okay. Then get ch. This is for our execution purpose and end of main. So this is what the program. So reading a matrix and writing a matrix. Observe here declaration. You have order of the matrix you have to read. So m and n variable should be declared of type integer, and the array has to be declared of with maximum size. Okay. Of course here m value will be 3, n value will be m value will be 2, n value will be 2, 2 cross 2 matrix. But we have taken enough locations here, maximum 100 locations, 10 and 10, 10 rows and 10 columns. Up to 10 rows and 10 column matrix can be read and printed here. And ij are the variables of type integer for loop. See, for loop uses variable I, and inner for loop uses variable j. So they have to be declared. Okay. Every time you have to read the element, so that's why ampersand you have to use ampersand a of ij, because each element of the array has to be accessed by 2 subscripts along with the array name. So that's why a is array name, first I is the square bracket I is the row number, second square bracket j is the column number. Even in during printing also, here no ampersand is written, a of ij. Okay. So this is what the program. So let us run the program and see what will be our output. Okay, how to give the elements, what happens, let us see. So this is the program, same program I have copied here. Same program I have copied. Okay, m and n are the variables declared, a 10 10 array declared, ij loop variables declared. Same, read the values of enter row size, column size, scanf m comma n. That is order of the matrix. Then reading the matrix, then writing the matrix, end of the program. So let us run it. Let me enter row size, column size. I will give 2 2, means my array is set to have 2 rows and 2 columns. So I have to enter 4 elements. Enter matrix elements. So 2 rows, first row elements I will enter 1 2. Enter second row elements I will enter 3 4. 3 space 4. Okay. Now see the output. The given matrix is 1 2 3 4. Okay. This is how. This first one is for reading. Second one is writing the matrix. Once again I will just execute it. Enter row size I will take 3, column size I will take 3, 3 rows and 3 columns. So totally now I have to give input 9 times, 9 elements. Enter matrix elements. So first row elements, what are your row elements? Let me take 3 5 1, first row elements. Next second row elements 6 2 3. Next third row elements you have to give 8 4 1. Okay. So this is reading the matrix. We have input these values. So that's why these are corresponding to scanf statement, reading the matrix. Now writing the matrix code is executed and it brings these elements onto the screen. See, the given matrix is 3 5 1 6 2 3 8 4 1. So this is what called reading and writing a matrix. Okay. Suppose instead of this I will rerun it. Just for your understanding purpose I am telling you, enter row size, column size. I will take just 2 only, 2 rows and 2 columns. I will give enter matrix elements. So in a single row I am going to give the elements, and of course it will take and print in the matrix form. See, 1 2 3 4. See, the given matrix is 1 2 3 4. Okay, once again I am going to run it. I will take once again 2 2. I will give one by one below the other. 1 2 3 4. These are my matrix elements. Okay. However, you can give your scanf statement is going to read those elements. Okay, this is how in different ways you can read the elements. Okay. So now I have told you, in printf statement, if I don't write this line, what happens? If this printf is removed, I am going to remove that line. See what happens. Enter row size, column size. I'll enter 2 only. I'll take 2 rows and 2 columns. Enter matrix elements 1 2. Then I'll give 5 6. These are my 2 rows and 2 columns. See how the output will be. the given matrix is 1 2 5 6, means next row elements are printed on the same line because I have removed backslash n, printf backslash n. So that's why printf backslash n is very important. Okay, so here we have to write printf backslash n within inverted comma. I have to write new line character. Backslash n is called new line character. Okay, this is very important. So I'll give 2 rows 3 columns. Enter matrix elements. 2 rows means 1 2 3, another 6 4 5. The given matrix is 1 2 3 6 4 5. So this is how you can read the matrix and write the matrix. So remember, the reading the matrix and writing the matrix code is always common. This is always common for all matrix problems. So this is always common for all matrix problems. So this is reading the code, this one, and this is writing the code. This is writing the code. This is writing the code. Writing the matrix. Say suppose if you remove these braces, what happens here? This for loop contains how many statements? Only one statement. If I use only one statement, these are not necessary. You can remove it. Okay. And this for loop contains how many statements? This from here to here, how many semicolons are there? So many statements. So from here to here, how many semicolons here at the end? So you have only one semicolon. So that means from here to here, it is only single statement. When we use single statement, then this curly brace is not necessary. So you can remove it. So this is also the code for reading the matrix. See? Just 2 for loops, scanf statement. You can read. Okay. See. 2 rows, 2 columns I'll take, no problem. 1 2 3 4. See, 1 2 3 4 means even if you remove those pair of curly braces, no problem. Okay. Whereas for printing, if you remove those curly braces, if you remove these curly braces, what happens now? See, observe the output. Okay. Two rows, 2 columns. I'll give 1 2 3 4. See, the given matrix is 1 2 3 4 means elements are displayed in the same line. So that's why their printf statement, this printf statement is compulsorily required. So that's why here we need to have, for this for loop, only this is the statement to print 1 row elements. After printing 1 row elements, then only this printf n should be executed. So that's why we are going to write here a pair of curly brace. So this is compulsory here, curly brace. And because there are 2 statements for outer for loop, this is also compulsory curly brace. So you cannot remove curly braces there. This is compulsory. Okay. So whereas for reading the matrix, those curly braces are not necessary, but you make it a practice to include curly braces for easier understanding purpose. Okay. Easily, very easily, because it looks very common. If you use curly braces, then it will be reading a matrix will be almost similar to writing a matrix. Okay. And then the for loop body you have to indent for easier understanding purposes. Scanf is indented from inner for loop, and this inner for loop is not exactly written below the outer for loop, just slightly it is indented. This is what called readability or programming style. So this is all about the program which is written to read a matrix and write a matrix. Okay, so this is how in this session we have discussed what is a 2-dimensional array, how to declare 2-dimensional arrays, and how to initialize 2-dimensional arrays, how to read 2-dimensional arrays, and how to write 2-dimensional arrays. Okay, so in the next class we shall discuss about some other problems on these 2-dimensional arrays, that is matrices. Okay, so thank you for watching my video. Thank you.